Importance of pH paper. What is the importance of pH paper in our daily life? Now, first one is pH range in plants and animals. How plants and animals life related with pH range? If pH range is near to 7.0 to 7.8, then our body works proper. Healthy human being pH range is 7.0 to 7.8. That is nothing but equal to water only. Next one, living organisms. Living organism can survive better with a narrow range of pH. Narrow range of pH means near to 7. Near to 7. That is value of neutral. Now next coming to point, pH of rainwater. pH value of rainwater below 5.6. It is called acid rain. See, if it is acid rain, it affects the crops. Agriculture is affecting by acid rain. That's why low pH value is better to crops. Next one is pH of rainwater. pH of rainwater also affecting affecting aquatic life also. Survival of aquatic life becomes difficult. Whatever animals are living, fish and whales, dolphins, whatever living in the water, that life will becomes difficult if pH range. If acidic property, if it is more in the pH value, it becomes difficult to survive to aquatic animals. Now pH range in soil. See, plants need specific range of soil. See, if you want to grow the crops properly, low range of acid required, that should be equal to or maybe very near to neutral value, that is pH value 7. When pH value is very near to 7, we can grow the crops very easily, and if pH value is more, that affects the crops, and due to whatever we are using artificial fertilizers, that artificial fertilizers are increasing the pH value in the agriculture field. That pH value in the agriculture field also difficult to survive plants. Now next coming to self-defense by animals and plants. Some animals and plants also for self-defense releasing acids. For example, bee stings and honeybees are releasing formic acid. Nettle leaves are releasing formic acid. This when nettle leaves are injecting acid in our body, immediately we are feeling irritation. It causes pain. We are feeling as a pain. Now next coming to point. This is about description of pH paper. Importance of pH paper. Now once again, if we recall all the topics, pH is P means potence, H means concentration of hydrogen ions. It is discovered by Sorensen. And pH value, that scale is marked from 0 to 14. That byju colors we are showing on the pH paper. Neutral is 7, weak strong acids starts from 0, weak acid starts from 4 to 5, 6, 7, and weak bases starts from 8, 9, 10, and strong bases starts from 11, 12, 13, 14. Okay, this is about pH paper and importance of pH paper. pH range is very important to plants and animals, and if pH value is very near to neutral, that is 7.0 to 7.8, that living organisms can survive very easily. Healthy human being pH range is 7.0 to 7.8, and the range of pH value below 5.6, it is called acid rain. And one more thing, the pH value of our mouth is 3.5. pH value of our mouth is 3.5 or nearly maybe 3.5 to 5.5. Actually, early morning we are applying toothpaste on our teeth. At that condition, the pH value of toothpaste is 8.0. When we are applying toothpaste on our teeth, immediately whatever releasing acid in our mouth, that acid is combining with toothpaste base. Then it becomes neutralized. Then when it is become neutralized, immediately turning into water and salt, it is that acid whatever is releasing in our mouth, it is not affecting our teeth. We are not getting any tooth decay. We are not facing due to this pH value. Now next coming to Salts, types of salts. Now we are discussing about types of salts. Before going to salts, now how we are separating salts. First of all, see in the water, we are taking salt water, we are taking, and electrolysis process we are performing. Electrolysis process means we are using anode and cathode rods, graphite rods we are using. Anode means plus, cathode means minus. Cations are releasing. Cations means plus ions, positive ions are releasing at the cathode, and anions means Cl minus ions are releasing at the anode. Okay, this Cl2 is chlorine is releasing at anode, and sodium is releasing at cathode. And sodium chloride solution we are calling as brine solution. Sodium chloride solution we are calling as brine solution. When sodium is mixing with water, then it is making a sodium hydroxide and hydrogen gas. What is how sodium hydroxide behaves, how hydrogen behaves, now we are going to discuss. In the electrolysis process, sodium is mixing with water. Whatever sodium is releasing at anode, that is when we are mixing with water, it is releasing a sodium hydroxide and plus hydrogen. Mainly, what is the main, whatever you use the hydrogen, the main use of hydrogen we are using as a industrial fuel. It burns very easily and it releases the pop-up sound, and this hydrogen we are using in ammonia for fertilizers and margarine. This hydrogen we are using as a margarine. This margarine we are going to prepare artificial butter and vegetable oils. In the vegetable oils, in the dalda, we are using this margarine. This margarine and ammonia, industrial fuels, mostly we are using hydrogen only. Next one, coming to chlorine. Chlorine we are using in water treatment plant. To kill the germs, to purify the water, we are using chlorine. And swimming pool clean and pesticides. The pesticides also we are using chlorine, and disinfecting water too. And next one, chlorofluorocarbons and polyvinyl chloride. In this levels also we are using chlorine. Next, in this, whatever used the sodium hydroxide in the electrolysis process, whatever we are getting sodium hydroxide, one of the salt or base, we are using decreasing metals. In the electrolysis process, whatever is releasing sodium hydroxide, we are using in decreasing metals. Artificial fibers and paper industry. In the artificial fibers and paper industry also we are using sodium hydroxide. And soap detergent formation. In the soap detergent formation also we are using sodium hydroxide. And next, in this, Cl minus means anions are releasing at the anode, that is hydrogen, H2, both are combining and preparing a hydrochloric acid. This hydrochloric acid using to clean the steel items. In the cleaning steel items and ammonium chloride formation, NH4Cl, ammonium chloride formation we are using this HCl. And in the medicines and cosmetics also we are using this HCl. And this HCl we are diluting and slowly acids slowly we are mixing with water, and with the help of stirring rod slowly we are mixing and we are preparing dilute acids. Dilute HCl acid we are preparing. We should not mix directly water with acid, maybe any damage may happen. That's why we have to mix acid with the water only. Next, coming to point, sodium hydroxide when mixing with the chlorine, we are preparing sodium hypochlorite or otherwise sodium oxachloride. That is, we are using to bleaching fabrics. To clean the fabrics, we are using sodium hypochlorite or sodium oxachloride. And the domestic bleaches also, in the domestically in the cleaning, we are using sodium oxachloride. Next, coming to bleaching powder. How bleaching? Calcium hypochlorite or calcium oxachloride, CaOCl2. In this calcium hydroxide is, we are sending, that is slaked lime. In that slaked lime or lime water, we are sending chlorine gas in this. Then it is happening calcium oxachloride, CaOCl2. Calcium oxachloride plus water. This CaOCl2, calcium oxachloride, we are calling as bleaching powder. This bleaching powder using in cotton industry, textile industry and linen industry, and this bleaching powder to remove the oxidizing agent. We are using as oxidizing agent and disinfecting drinking water. To remove the infection from the drinking water, we are mixing a bleaching powder. Next, we are going to discuss about baking soda. Baking soda. Baking soda is sodium bicarbonate. Baking soda NaHCO3. Sodium bicarbonate is called as baking soda. Next one is washing soda. Sodium carbonate Na2CO3. Washing soda Na2CO3, baking soda, sodium bicarbonate. Now next, in the form of salts we are getting. In the salts, if you are discussing about salts, NaCl, how it is performing electrolysis process, and how chlorine, how hydrogen showing actions, and how sodium hydroxide combining with chlorine, how it is preparing bleaching fabric, Na sodium hypochlorite. And next one is how bleaching powder is a part of salt. Calcium oxachloride, calcium hydroxide is mixing with the chlorine, then it is giving product as a calcium oxachloride plus water. It is using in cotton industry, linen industry, textile industry, to paper industry, and to remove the infection from drinking water. In this ways we are using this salts. Now next one is last and final one is bleaching powder, washing soda, baking soda. And the baking soda is the one type of salt. When sodium chloride is combining with water and carbon dioxide, and ammonia also mixing here, then it is making as a products ammonium chloride NH4Cl and sodium bicarbonate, that is sodium hydrogen carbonate. This NaHCO3 only we are calling as baking soda. This, when we are heating baking soda, we are getting again sodium carbonate, that is nothing but washing soda. Next one, water H2O we are getting in the form of products, carbon dioxide gas. We can check with lime water, it turns into milky. Now sodium bicarbonate is nothing but baking soda. This baking soda, in food items we are using this baking soda. Next, to prepare cakes in the crispy nature, to get the crispy nature we are using this baking powder, and it is using as a mild acid and to prepare antacid tablets. If we feel acidity in our stomach, to clear that acidity we are using this baking soda as an antacid tablets. Next one, this baking soda using as a fire extinguishers. To stop the fire we are using baking soda. Next one is washing soda. See, when we remove the hydrogen from baking soda, then we get the washing soda. Then sodium carbonate is mixing with them. Water, that is 10H2O, crystallization of water, that is 10 molecules of water. Sodium carbonate is mixing with the 10 molecules of water, then we are getting Na2CO3, 10H2O. That is washing soda, Na2CO3, 10H2O. This washing soda we are using in glass industry and paper industry, and next one, manufacture of sodium compounds such as borax glass, and it is using as cleaning agent for domestic purposes. And this washing soda removing hardness of water and bringing softness in the water and removing hardness of the water. Okay, this is the washing soda. Na2CO3 is combining with the 10H2O. And next one is this 10H2O is nothing but in the form of crystals. We are seeing water in the form of crystals. Why? Because water is combined with 10 molecules of water. 10 molecules of water is present here. That crystallization, by heating we can get the crystallization. We can make the crystallization process by heating. Next we are going to discuss about plaster of Paris. CaSO4 of H2O, calcium sulfate of H2O. Okay, we are using gypsum. Gypsum is nothing but calcium sulfate and water. Calcium sulfate is mixing with water and heating the gypsum at 373 kelvins, 100 degrees Celsius. At that condition, we are getting calcium sulfate of H2O, that is plaster of Paris. This plaster of Paris, with the help of gypsum, After heating at 100 degrees Celsius or 373 kelvins, we are preparing this plaster of Paris. With the help of this plaster of Paris, we are using in making toys, we are preparing Ganesh idols, we are preparing materials for a decoration, we are preparing, and a smooth surface we are making. And with the help of plaster of Paris also, we are connecting fractured bones. That fractured bones layer also we are covering with plaster of Paris. These are the main uses, so many uses we have with plaster of Paris. This is the plaster of Paris also one of the salt, one of the salt in this acids and bases. Okay, in that salt we are completed bleaching powder, baking powder, and plaster of Paris, sodium hydroxide, sodium chloride, electrolysis. These are all we covered in this types of salts. And potassium sulfate, calcium sulfate. These are all comes under the salts. Next, coming to a point, in this whole lesson we have covered types of acids, organic acids, mineral acids. Next, physical properties of acids. Acid sour in taste, acid sour in taste, it releases H plus ions, it conducts electricity. And physical properties of bases, it is bitter in taste, and bitter in taste, it releases OH minus ions, do not conduct electricity. Chemical properties of acids, reaction with acid and bases. Chemical properties of acids and bases. Acid reaction with the metals, metal oxide, metal carbonates, metal hydrogen carbonates. These are all we observed, acids and bases reaction. Next, coming to indicators, synthetic indicators, olfactory indicators, natural indicators, and these are completed. Universal indicator, coming to universal indicators, pH scale, total 0 to 14 points of pH scale, VIBGR colors in the pH scale. Next one, who discovered pH scale? These are all covered in this pH scale. Next, types of salts, bleaching powder, baking soda, and sodium chloride, sodium carbonate, sodium bicarbonate. These are all topics we are covered in this session. Thank you.